This is the first lesson of Unit 7, Pythagorean Theorem. So we have Pythagorean Theorem, a squared plus b squared equals c squared, which you can rearrange for b squared and a squared. So c squared minus a squared equals b squared, and c squared minus b squared equals a squared. Okay, so you can either use this formula that involves these squares, or you can use this one. It's the same formula, but instead of square rooting your answer afterwards, you can just get it in one step by having c squared equals square root of a squared plus b squared. C equals square root of a squared plus b squared. So c squared equals a squared plus b squared, right? You can move this squared over this side, so that becomes square root of a squared plus b squared, because the as you guys learned in Unit 3, the opposite operation of a square is a square root. So we have the square root of a squared plus b squared equals c. All right. Like the one here, you can rearrange it into b and a according to your question. So b equals square root of c squared minus a squared, and a equals square root of c squared minus b squared. Essentially, it's this formula, but you can solve directly for these variables without having the square here by square rooting the other side. Okay, so what does the ABC even mean? So this is the diagram. C, as in this a squared equals b squared equals c squared, C is the hypotenuse, which is the side opposite to the right angle. See, so it's opposite to right angle, and A and B are the legs of a triangle, of the right triangle, so they're the sides that are adjacent to the right angle. Okay, so let's look at an example. We have this triangle, we have C, you want to find C squared, right? You want to find C. So this side is going to be C. And we know that we have A and B here, 12 and 5, because they're adjacent to the right angle, as marked there. So we can just apply the Pythagorean theorem. So I used this formula here, C equals square root of a squared plus b squared. You just plug in, you have the values, you plug in a and b, so this is b, this is a, you plug in, so 5 squared plus 12 squared, and you have 25 plus 144 equals 169. You square root that, that'll give you 13 centimeters as C. Alright, so let's go through some examples. We have this triangle over here. Now we see that the opposite side from the right angle, the side opposite to the right angle, that's C. So C is given, and this is adjacent to the right angle, so this is, you can call this B. So you have this side I'm going to solve for. So now we can go back to the formulas. See, A, so you got A equals square root of C squared minus B squared. Okay, so you can just apply the formula straight away. So you got A equals square root of 13.25 squared minus 11.25 squared. Okay, you can plug this into a calculator. Let me just plug it in real quick. That will get you A equals 7 centimeters. Okay, so that's an example of us solving for a leg instead of the hypotenuse. Okay. Oh, and another very important thing is that you're gonna put brackets. All right. When you plug it into your calculator, you're gonna put brackets around these numbers before you square it. So it's just a calculator thing. So just be aware of that. You want to put the brackets there. Okay. Our second question. So this question is a bit more difficult, but it's still the same steps. So we're asked to find the perimeter of this composite shape here. So this is a square, this is a right angle triangle. All right, so we see these hatch marks here. They mean that these sides are congruent. So we have 12.8 given there. So we can say that this side here is also 12.8, and this is also 12.8, because it's a square and they have hash marks for us, right? So we have these 12.8 and 12.8 here. And now to get the area, you obviously want to get this side, and it's opposite to the right angle, so you can call that C. So when we can just apply our formula as said earlier. So C equals square root of a squared plus b squared. These two, 12.8 and 12.8 here, they are the legs, A and B. So we plug it in. All right, so let me just plug in the calculator. So A here is 12.8, and B is also 12.8. So C will be this number. It's important that we leave it in the exact form of the fraction, because you want to get the perimeter, right? You want to get the perimeter, so we want to leave it in the exact form and get all the decimals in, because if we round it too early to get this side, if we round it to like 18.01, right? If we round it too early, then our overall perimeter calculation would be affected. We will not get a really exact answer for our perimeter because we rounded too early. So for these multi-step questions where you have to find a perimeter using this Pythagorean theorem, then I want you guys to leave your fractions there. Okay, that's the first step. So we got that. So that's around, let me just write it down right there, 64 times root of 2 over 5. Okay, and these hatch marks indicate that these sides are also the same, 12.8, 12.8. So yes, for the perimeter, so the square here, so we need to have 4 times 12.8 to account for this. Oh, actually no. For this side doesn't really count as a perimeter, so you can just exclude that. So you have 3 12.8s. So 3 here, and then you have another 12.8. Right, you have another 12.8 here. So you get this side, this side, this side. Now you get plus C, which is let me just move this over. Plus C, which is going to be 64 root 2 over 5, and then you have, yeah, that's going to be it. So that would be our perimeter, right? So you have 3 times 12.8, because you want to get these 3 sides. Boom, boom, boom. You want to get those 3 sides, and you plus another 12.8 to get this side, and you add another this number here to account for this C side here. So you can plug that into your calculator, and our overall perimeter would be there's a lot of fractions. Our perimeter would be around 69.3. Yeah, so that is our perimeter for this composite shape. It's kind of messy, so I would just erase some stuff here so you guys can see more clearly what the composite shape, the original thing looks like. All right, yeah, so this is what the original thing looks like, and we got our answer as 69.3. we round it to 1 decimal place. It depends on the answer on how much decimal places it wants us to round it to, but I'll just assume that it rounds to the nearest to 1 decimal place. Okay, next question. We'll get to word questions later as well, so stay tuned for that. I'll move this over here a little bit so it's easy to look. All right. You're given this diagram and you're asked to find the area. Okay. So for the area, you first want to identify that you want to solve for this C. Okay. You want to solve for this this segment here, so that you can get the radius of this semicircle and then solve for the area, right? Because this is area 1, this is area 2. So the total area would be area 1 plus area 2. So the triangle has a base and a height, so you can use that to find the area 1. But area 2, you don't have anything, so you must use Pythagorean theorem to get this segment C, or hypotenuse, which is the diameter of the semicircle. You have it, you have that diameter to get the radius, and then you plug it into the semicircle area formula to get area 2. You add them together and get the total area. So just clean it up real quick. So we have the base of the triangle here, and we have the height. Okay, this base can also be called A and B because they're legs adjacent to the right angle, and this side opposite to the right angle is the hypotenuse. So let's calculate area 1 first. So I'll give you the formula: total area equals area 1 plus area 2. Okay, so now we have the area 1. So let's get the area 1. So area of a triangle is base times height divided by 2. Okay, so you just plug those values into the calculator. That would output around 13.95. That's your area 1. Good. Okay, you got your area 1 done. Now you must find area 2. As I said earlier, we have to get C, right? So let's get C by using Pythagorean theorem. C equals square root of a squared plus b squared. Okay, so let's do that. That will give you 7.6, but as I said earlier, you do not want to round it too early, so I'll just leave it as that, because my calculator doesn't give me a decimal, so I'll just leave it as that for now. Okay, so that would be our diameter, or this whole segment is C, right? But now we want to get only the radius, so that is the diameter of the semicircle. But now we want to get the we actually want to get the radius to get the area of the semicircle. So radius is half diameter, right? So you simply get that C over 2 equals radius. So radius, you divide this number by 2. That'll be 3.8. 3.8. Or you can just use C, or you can say that R equals that whole fraction. You can say that R equals that whole fraction. Or if you have a Casio calculator, there will be an answer key. There's a button on your calculator that has A and S. So it's like this: A and S, answer. So you can use that answer key to like sort of store your answer. So let's say you got like this whole C value, right? You don't have to actually write it down. It will automatically store on your calculator, and you can use that value by pressing the answer key. Okay, so you have the radius here. Radius is 3.8. I have my answer key, so I don't have to write the whole fraction down. Just get that away. So now we have the area 2. Plug in the formula. So pi r squared divided by 2, right? Area of a semicircle. So area 2 is going to be pi times 3.8 over 2. Obviously, 3.8 here is it's a rounded version, but on my calculator, I'm obviously use the actual answer key for that. So pi times pi squared divided by 2. That will give us 23.04. Again, this will be stored as your answer key if you have a Casio calculator. Okay. So you have both of your areas. So we can just plug it into the original formula for total area equals area 1 plus area 2. Okay, so we got area 1, which is around, 13.95. And then area 2 is that. So area total, you add those two values together, which gives you 36.99, round it up to 37. So you always round at the end, okay? So I want you guys to round to these calculations in the middle here. Do not round there. Use the exact answer. Only round it at the final step. All right. So you want to round it at the final step. Okay. So that is an overview of this of this question here. Let me just erase some stuff so it's easier for you guys to see the actual question. So this is the original question here. So we got the total area as 37 centimeters squared. Yep, I forgot. Yep, centimeters squared will be our final answer. Okay. So we have another, we have a word question here. Let me just drag it down real quick. Okay, we have a word question. These word questions are typically going to be on your exam or your test, so do not skip them. They're quite important, so do not skip them. Change the color real quick so it's easy to see on the white background. Actually, I don't really have to. Okay. So it says, in a game of baseball, the distance from the one base to the next is 90 feet. So they labeled the diagram for you. It's pretty easy. From this base to this base, let me just use blue. From this base to this base, it's 90 feet. So distance from each base is 90 feet squared. Okay, and you want to get the distance from the home plate to the second base. So it's essentially this distance. Oh, something happened. So it's essentially this distance. Okay. It keeps lagging. Okay. You essentially want to get that distance. Home plate, second plate, and you want to get that distance between them. Like that. Okay. So this is a classic Pythagorean Theorem question. You have 90 and 90 as the two legs. This is a right angle here. So the opposite angle to it is a hypotenuse. We'll say C. So you're trying to find C. And you have A and B there. 90 feet. Okay. So again, the formula, C equals A squared plus B squared, square root of A squared plus B squared. So C, you just plug in the values straight away. that will give you 90 root 2. That's your final answer for the distance between the first base and the second base. Boom. Easy. Easy nailed question. So you have to really interpret normally on exam they would not give you the diagrams, so you really have to actually interpret the question. It really depends on the teacher and also what courses you're taking. So if you're taking a D-stream course, then they would give you that diagram, as you can see here. But if you're taking higher level courses like IB or something like that, then they will not give you the diagram. You have to actually interpret it. So, but sometimes they will give you a diagram like this one, which is really good because you can just you can label it and you can really see how it actually comes into life. Okay, so perimeter. Find perimeter. This is a classic sort of IB sort of question here. It can also be in D-streamed programs as well, but in the IB on your IB tests, this is a pretty first few questions look similar to this one. All right, so you have this triangle here, and you're asked to find the perimeter. Okay, we see that they labeled hatch marks here, which means that these two sides are actually congruent, right? It's an isosceles triangle. So in order to find these two sides, we can use, and we have a right angle here. So we know that it's a right angle triangle. And this is the hypotenuse because it's opposite to the right angle, right? So we have c squared equals a squared plus b squared. I usually don't jump into this formula yet while solving these unknowns. When there's two unknowns, there's no angles, I would not use this formula because I want to start off with this to be more simple and easy for me. See? Okay. So for these types of questions, I would usually use a normal formula. So c squared equals a squared plus b squared. Okay. You have c squared here. So 28.3 squared equals a squared plus b squared. However, a and b here, they are the same. They're the same side. Because these two are the same, so you don't have to write it as a squared plus b squared, but you can just write it as 2a squared, right? Because these are both a's. They're the same leg. They're not the same leg, but they're the same length. So they can be considered as a, the same value of a, right? So because in a isosceles triangle, let's say that a is, let's say 7. Then these two are both a. So you don't really have to write 7 squared plus 7 squared. You can just write 2 times 7 squared. You know what I mean? Okay, so let's go back to the actual question. So you have a squared. So you have a here. You can label both these sides as a. So that formula will give you a squared plus a squared. Because b turns into a anyways. Okay, so you have 28.3 squared equals 2a squared. And then you so you can evaluate 28.3 squared. That will give you 800.89 equals 2a squared. You isolate for a, so you 800.89 divided by 2, which is 400.445 equals a squared. So a would be square root of that, square root of this. So that would be around 20.01. Of course, you don't round here, but I'm just writing it for you guys to visualize to really visualize it. So I'm writing it down here, but on my calculator, I still have it there. I still have the exact answer. So a equals the square root of that, to be exact. Okay. So you have your a value. So these are both a's. Okay. So your a value is going to be around 20.01. Of course, not exact, but rounded. So now we can just plug it to the perimeter or triangle formula. right? Because you have these two sides are both A, so they're both 20.01. So you have all these sides, you can plug into the perimeter formula. So it's going to be 2 times 20 plus 2 times 20.01 plus 28.3 plus perimeter. I did 2 times 20.01 because 20.01 plus 20.01 is the same thing as 2 times 20.01. So P perimeter would be around 68.3 centimeters. Oh, millimeters. Wrong on units. Okay, there. That would be your perimeter. So this is an overview of Pythagorean theorem, and I hope you guys enjoyed.